Hi, so today we're going to be doing our ML project proposal. So to start off, exoplanets are worlds beyond our solar system. They're defined as planets that exist outside of our solar system. And the goal of our project is we actually want to classify their habitability. So there's some key factors, including their distance from a star, their size, composition, temperature, atmosphere, etc. And we want to use these metrics in our machine learning models to be able to predict if that habit is, or if that planet is habitable or not. We'll be using the PHL-EC dataset that Basic et al. And many others have used, and we'll be implementing a couple algorithms for that. So the current challenges are that there's thousands of exoplanets with extensive data, but there's no standardized method for habitability assessments. So this is really a time-consuming analysis, and our goal is to be able to use techniques such as PCA to process our data, as well as implement some machine learning models to actually determine the habitability. So for our methods, for our data handling, we want to remove columns with over 70% missing values, and we also want to use median imputation and k-nearest neighbor to fill in some of the missing values in our features. We also want to scale our data using min-max scaling or z-score standardization, and because our dataset has over 100 features, we want to use dimensionality reduction using PCA to reduce the dataset and make it reduced overfitting. As well as our data preparation, we want to split the data into our testing and training sets, and we want to address the class imbalance of our habitable planets. For our models, as our baseline metric, we're going to be using logistic regression. For our tree-based methods, we're going to be using decision trees, random forests, and XGBoost. We're also going to be using SVM, which is very effective in high-dimensional spaces. And then we're also going to be using a multi-layer perceptron. So for our results and metrics, we want to evaluate the performance of our model using several quantitative metrics. Our accuracy, we were looking for over 80%. Our precision, we're looking for over 70%, recall over 75%, and an F1 score of over 70%. And that's all.